This is an investigation into a problem that customer reported, which is my indexing gets stuck. That's the problem statement that will land on you as a developer. Now, what we need to figure out is what does it mean that it gets stuck and what is really happening. Now, the setup that I have has a large catalog which is very similar to the catalog that the customer has. In fact, this is a bigger catalog. You can see that the price index table almost has 43 lakh 28,000 and something records, right? Which is a large table. And the price indexing takes a long time to happen. When this problem statement initially landed on me, um, this was the bug that customer reported, which is price index is getting stuck. That's what the customer said. Then what did I do next? Um, I logged into the server and I checked if the crons were running. And I saw that the process was running for about 2 hours, and then I needed to know what this indexation process was really doing behind the scenes. So I used a Linux tool utility which I use quite a lot is strace. And when I straced the process, it told me that this query was being fired and this query took a really long time. And when I noticed it, I also went to AWS RDS logs and looked for the slow queries. And this query was the slowest query that was running. Then I needed to figure out why is this query being fired and what code is responsible for firing this query. And I landed on this particular pricing model, price indexing model, and a function name delete outdated data. So let's quickly take a look at this. And now if I scroll down, let's see if we can find that particular um, this is full. we are we don't want to look at the full indexer. This we are going to look at product price indexer rows execute IDs since the indexation was set to schedule. And now let's look at reindex rows. Okay, and when we look at reindex rows, I'm not sure if I should put this in production sorry um, full screen view, so just give me 1 minute. Appearance, let's go to full screen view so that we see this better. Now let me zoom in. Yeah, now if we see here, there's this function called delete outdated data, and we look at this, we see the exact same query being fired on this TMP table. And we will get into what this does, but you can check that there is a one liner comment which is delete records that do not exist anymore, right? And this by itself will not make a lot of sense unless we deep dive into what is this indexation process doing, and in the larger context, how is this delete outdated data fit. One thing that we really need to understand is the full indexer and partial indexers have a completely different function calling, or you might say call graph, have a very different functions responsible for indexation process. Now, there are some GitHub issues that you will see related to this particular change, and how to find that. If you look at, say, I already had this, I think, this particular commit that I had. If you look at the commit log, it says price indexation optimization, and then there are changes related to uh, this whole code. Now, let's see how we can debug this. This is going to be a complete impromptu session. I don't know really how I'm going to debug this, and nothing is pre-decided. So let's see. First thing that I need in order to before we start actually, let me give you a full dump of what all I already know. So let's go back to price indexation and look at this particular table that I have here. Catalog product index price. This is the main indexation table, index table, where the prices are stored, and this is the table that is used for product listing pages. But imagine if you were re-indexing and you emptied this table, what would happen? If while re-indexing you directly delete data from this table and then spend time calculating the prices, what will happen is for that duration the product will disappear from the front end. If the record doesn't exist in this table, the product will disappear from the front end. So Magento never really deletes any data from this table. It's not completely accurate what I'm saying, but in partial reindexing, you will see that it doesn't delete data. It doesn't delete relevant data from this table. It will only delete outdated data. And now let me also tell you what does this outdated data mean, right? For example, pay attention to the columns entity ID, which is product ID, customer group ID, website ID, and that's how the prices are stored, right? This combination of entity ID, customer group ID, website ID is a unique combination, and you can in fact see that in structure that this is a unique key. Entity ID, which is product ID, customer group ID, website ID is a B-tree unique key index. Now, what happens if you delete a customer group completely, right? Then all those records related to that customer group ID are irrelevant. Same thing happens if you delete a product, or if you delete a website, or you delete that product from the website, right? Then all of those records become irrelevant, right? So you don't need to update them, you simply need to remove that data. And that essentially is what it means to delete outdated data, right? Now, having this context, let's go back to how Magento performs reindexing, partial reindexing at least. The complete calculation happens in a completely separate table, which is catalog product index price TMP. Uh, and if you really look at how it works, this is not the table where Magento inserts things. Magento will create a table similar to this by using this as a template, and we are going to do the same manually, and then it will insert all the records there, and then it will do an update on this update from select, or insert from select, on update, on duplicate update, right? This is the kind of query that Magento will fire. That is essentially what is happening in the background to ensure that products don't suddenly disappear, because you don't want your page to be cached when the product disappeared from the page, right? That would be a big problem. Now, with that, let's start our indexation, our investigation. Now, one thing that I know on why this particular query, which is responsible for deleting outdated data, is slow is because if you look at the TMP table again and look at the structure, right? It does not have that same unique key combination on entity ID, customer group ID, and website ID. It does not have unique key, which means when I query this table, it will take a really, really long time. And let me demonstrate that to you, right? And Of course, when you add indexes, it has other side effects. So you need to be really careful when you design a solution around this. Maybe what will happen is if you just put an index here, then your partial indexing will become quick, faster, but your full reindex will probably be slower. Or even partial indexing will be slower, but a different query will be slow, not this drop query. And let me demonstrate why I am saying what I'm saying. Next, notice how not having an index affects the insert performance, right? So let's do what Magento does. Let's create a table from this as a template, right? So let's say create table like. This is the statement that Magento uses internally. Create table, catalog, product, and I'm doing exactly what Magento does. I know this because I had investigated this a little before recording this video. Create table, catalog, product, index, price, temp, like. This is what Magento is really doing to first create the table. Now, when I create this table, the table definition will be copied. Create table like does not copy the data, and anyway, this does not have any data. Now, let's take a look at this table that has been created. Let's go here. Let's look at this. And let's look at the structure. This structure is exactly the same, which means entity ID, customer group ID, website ID, they do not have unique key constraint. Now, not having an index, you will obviously think, okay, so the selects are going to be slow. So maybe I should put an index here. But let me also show you uh, the insert speed without indexes and the insert speed with indexes. How inserts become slow when you have indexes, right? So let me quickly do this. We are going to dump a lot of data here from catalog price index table. So we are almost going to dump 48 lakh records, right? I think it's 500,000 records, almost 500,000 records. So let's look at this. What I'm going to do is insert into this table and from this select, except before inserting I need to be careful of one thing, that this table has this additional column called ID, which the original catalog product index price does not have, right? So I'll have to do something like dot star, and for last column I'll be doing null. This is an auto increment column, so automatically it will be populated by MySQL. So let's look at the time that it takes, and then we'll look at the time uh, taken when we add indexes. So let me copy this. I am going to do this on my command line MySQL. So let me zoom in here. Okay, MySQL minus U, right? Sorry. Okay, now we are in MySQL. I'm going to say use Magento 2. I think that's the name of my database, Magento. That's oops. Okay, now let's fire that query and see. And to answer the question, why am I not doing here and why am I using command line? The simple reason is if this query takes a long time, I'll get a 504 timeout here, which I don't want. So I'm doing this on command line. So let's do this. Insert into catalog product index price temp table. Select data from the price, all the columns, and an additional null column from catalog product index price. Okay, let's fire this query and see what happens. We will get the results, but I'm sure that this will not take more than a minute, or at least shouldn't take more than a minute, since there are no indexes on this table. So let's see how much time this actually takes. As you can notice, the query finished in 46.81 seconds. Uh, the rows affected are around half a million, 53 lakh 12,000. Let's just see how many rows are in here. Select count star from this particular table. Let's see if we have all the records, and let's see how many do we have in our this table. Yeah, so you can see we have inserted all the records from catalog product index price into uh, price TMP, and the insertion took 46.81 seconds. Now let me show you what happens if we do a insert statement when there are column constraints that we have put, right? And inserting takes more time if you have unique key constraints, especially complex composite keys, where the unique key is combination of multiple keys like entity ID, website ID, and customer group ID. It takes more time because every time before you insert the record, MySQL needs to check if there is a duplicate, if the record already exists, right? That additional check is what will take time. So let me prove that to you. Let's quickly drop this table. Sorry, drop table, right? We have dropped this table. Now let's recreate this table, but this time we will have schema which is similar to product price index table, which is catalog product index price table, right? Because in that table, this constraint is already there. And let me show you this. Let's say create table catalog products in index price TMP like catalog product index price, right? Let's do that, and let me hit enter here. Okay, now let me show you the table schema. Show create table, this particular table, right? So let's do this. Now if you check, you see that the primary key is entity ID, customer group ID, website ID, and this is also unique because primary keys, this particular thing, we have marked this as unique by saying that this is a primary key. Now let's go further and let's insert records into this table, which is we'll fire our old query, which is insert into catalog product index price TMP, and I'll just remove this null because I've removed that additional column. Select catalog product index price star, and now we will see how much time does this query take. As you can see, this query took 1 minute 21 seconds. The previous query, previous insert took only 46. I shouldn't say only. It took 46 seconds when the indexes weren't there. But as soon as I add indexes, you can quickly see that the query time goes up. The insertion time goes up. And as I said, that happens because before inserting, MySQL has to check if the records will be duplicated. So having said this, the reason to talk about this is in this price indexation performance improvement commit that was made into Magento core, this particular commit, you can see that um, that constraint was removed. Initially, the TMP table had the same constraint like the original price table. In fact, those tables were exact replicas of each other. But you can see that this constraint was removed and a different constraint was added, which is this new column that has been added, entity ID. Now, I would like to take a pause here and mention that the commit message for this particular large, really large commit is just price indexation optimization, which in my opinion is a really bad commit message, because right now when I am looking at this code or I'm reviewing this code, I can't tell why was this decision made. Commit messages should effectively um, communicate the thought process of the coder. Like it could be domain knowledge that's there, or certain considerations which were made while making this change. It helps other developers to figure out why this change was made, and this also helps you to preserve the optimizations which were made for this use case, and also optimize it for other use cases. For example, I believe that this was done for a full reindex process, but it accidentally uh, degraded the performance for partial indexes. And another thing that I couldn't, another piece of information that I couldn't find for this was the information on the tests. What tests were run to ensure that yes, the performance has indeed improved. Uh, was it run for large code bases or large databases? I don't know. Large catalogs? I don't know that. Right? I would prefer the commit messages to tell me why this change was made. Uh, but okay, apart from that, you can see that this constraint was removed. I believe it was for optimizing the inserts. I don't see any other reason why someone would remove this constraint, because as a result, what's gonna happen is this query is gonna slow down. This particular query in question is going to slow down. Why will it slow down? Pay attention to the left join here. Left join relies on a where condition here, right? And also what will happen is this condition now cannot use indexes anymore, and because of that this join will have to scan more rows. And let me show you that, let me demonstrate that to you. So since we already have that table, let's look at the explain for this delete query. So let's do a quick explain to check what is the MySQL query plan. Explain this. That's what we are telling MySQL to do. Let's look at this and let's look at the MySQL plan. See, it's saying that it only needs to scan hardly 400 rows, or not more than that, because I mean it somehow figured out that I can use these indexes, and because I'm going to use these indexes, I'm not gonna have to scan a lot of rows. The estimated row size is really low. Now let's check what happens when you don't have those indexes, right? So let's just drop these indexes from the table. Let's go to structure. Let's okay, let's not do that. Let me just do exactly what Magento does, right? So let me first drop this table that I had created. Drop table. Now let's recreate this table just like we had created before. Create table catalog product index price temp, like create table this like catalog product index price temp. This table is a template table. Template as in you won't insert anything here, you'll simply use it as a template schema. Now that's done. Create table catalog product index price temp. Let's create that, and now let's insert into this table. We'll need that additional null column, right? So let's just insert here. Okay, um, this particular insert has finished. Now let's quickly go ahead and check that explain again. Last time we took that the rows that it had to scan was really low number of rows. Now let's take this again. Let's go and let's do a explain here. Explain, and let's say go. Okay, now if you check that previously the condition was where it had to only scan couple of rows from here and not a lot of rows here, but now you can see the situation is very different, that this is gonna take a really long time to execute. And in fact, let's see how long does it take really. Let's paste it here and let's see how much time does this really take. 1 2 3 4 5 6 7 8 9 10 11 12, and this can go on. Let's see. And as you can see, the query took 1 minute and certain 1 second. This delete query took this much amount of time. 0 rows affected because none of these product IDs now exist. We just copied, but irrespective of that, it shouldn't have taken such a long time. And this tells us how this query really is slow. And let's see what happens if I have indexes on this particular table. So let me quickly create indexes and let's resume our investigation. As you can see, I have just provisioned, I've created a similar table again with the indexes, relevant indexes. You can see that indexes now exist. Let's look at what our explain says. Review, let's review again. Explain to me this. Go. You can see not a lot of rows to be scanned, and now I'm confident enough to run it here. I know this is not gonna take a long time like the previous one took, right? It took 1 minute. Sorry, this was completed, but the delete query here took 1 minute 1 second. Now let's see how much time does this take. Nothing. Really fast, really fast. Why? Because of indexes. But so far we have discussed two things. If you add indexes, the insertion time goes up, as evident here. Insertion time without indexes was around 35 seconds. Insertion time with indexes went up to 1 minute 18 seconds. But the query time drastically reduces. If I try to delete those query, I fire the delete query on a non-index table where the join cannot use the indexes. The query takes almost 1 minute 46 seconds. But if I can use indexes, this query just finishes very quickly. I mean, 0.0027 seconds. really fast. So it's very important to understand the impact of indexes on both insertion and selection. Delete query in itself takes time because there is before you delete, you need to find those records to delete, and to find those records you're using the join condition, and that on condition which contains a where clause like condition, right? uh, so if you don't have indexes, you run into these problems. So when you design schema, you have to think about, is your table insertion heavy? Are you going to insert a lot? Or is it read heavy, which is you want to read a lot, right? And depending on that, you need to choose columns, and the schema design has to consider all of these things. Now in next video, in this video I have given all the context that I have. In next video I'm just going to do a free exploration where I don't know much, and it will be probably a longer video because I'll be experimenting and not be able to give information in a very structured way. But that's about it in this video.